So I want to conclude this section with a review of basic differentiation rules. And for that, I need the concept of an elementary function. And that's a function from the list below, or one that can be formed as the sum, product, quotient, or composition of functions in a list. On the left side, we have our algebraic functions, such as polynomial functions, rational functions, and functions involving radicals, like square roots or cube roots, etc. And then on the right hand side, we have the transcendental functions like logarithmic functions, exponential functions, trigonometric functions, and inverse trigonometric functions. Now, with the differentiation rules you've learned so far, you can differentiate any elementary function. So certainly we've talked about the derivatives of all of these functions. So for polynomial functions, we're mostly using the power rule. For rational functions, we can use the quotient rule. For functions involving radicals, well, think of radicals as powers, fractional powers, and you can use the power rule. In this class so far, we talked about derivatives of logarithmic functions, exponential functions, trigonometric functions. That's something you learned in Calculus 1. And then derivatives of inverse trigonometric functions, we just talked about that. Now, here it says we could also take the sum or the product or the quotient. Well, if you do that, you take the sum of two functions and you mix and match. The derivative of the sum is the sum of the derivatives. If you use a product of two functions, you can use the product rule to break it down. If it's a quotient, you can use the quotient rule. If it's a composition of two functions, for instance, you plug in an exponential function into a polynomial function, then we can use the chain rule to find the derivatives. So this is really true that with the differentiation rules you've learned so far, you can differentiate any elementary function. Later, we will see that that is not the case for finding antiderivatives. That's a lot harder. So here we have some basic differentiation rules. I'll highlight a few. We have the product rule here. Derivative of a constant is 0. The quotient rule here. We have the derivative of a sum is the sum of the derivatives. And then we had a couple of derivatives that we talked about in this class. Derivative of the natural log, derivative of the exponential function with base e. And then we have some other bases for the log and for the exponential functions, derivatives of the trigonometric functions, and derivatives of the inverse trigonometric functions. So again, this is not a list that you will have to memorize. The handout that I provide on the exam that is available on D2L has all of these rules available. So you will be able to reference that on any exam. So what I will do now is I will write down the answers of the in-class practice problems. So this is basically your unofficial homework, and I will then upload those answers to D2L.